Let me introduce Ali. Ali is a MSc student at the University of Alberta in the Computing Science Department under Osmar Zain. So he's also an ML engineer, data scientist, NLP researcher, and member of the Alberta Machine Intelligence Institute. And he has been developing this app for addressing mental health issues. And that's what he'll talk about today, which is Mira, the mental health virtual assistant. So over to you, Ali. The floor is yours.
Okay, thank you. My name is Eliza Zamani, and as it said, I'm a master's student in computing science at the University of Alberta. I'm doing my thesis, my master's degree under supervision of Osmar Zaya. I want to start my presentation with an introduction video regarding our team.
Hi, my name is Jasmine Noble. I am a postdoctoral fellow from the University of Alberta in computing science and psychiatry.
Hi, I'm Isabella Nicolaides. I'm a project assistant with the Mood Disorder Society of Canada supporting this project.
Hi, my name is Eliza Zamani and I'm a master's student in computing science at the University of Alberta.
Hello, my name is Mohammad Ali Qaraat. I'm a master's student in Department of Computing Science at the University of Alberta.
We are the team working on the development, implementation, and evaluation of the Mira Chatbot, a conversational computer program that uses artificial intelligence and machine learning to support Canadians in finding information on mental health services and programs. I'm a recent graduate of information studies, and working on the Mira project has given me the opportunity to learn and collaborate with leading researchers, programmers, and healthcare experts.
Thanks to this project, I have a great opportunity to learn and get experience in high-tech NLP topics. It is also interesting to me that our first prototype of this chatbot will be piloted out to support healthcare workers and their families.
I find this work meaningful. This project will help support our healthcare workers who have been greatly impacted by the pandemic. They deserve our support now more than ever. The other reason is that it will support my professional development in natural language processing and in the development, implementation, and evaluation of chatbots. From all of us here on the Mira development team, thank you.
Thank you.
Thank you.
Okay, cool. I will begin my presentation today with a quick overview of the need for a new technology that seeks to bridge gap in mental health service provision. Following this, I will describe our innovation, namely the mental health system navigation chatbot named Mira. Then I will provide an overview of the Mira portal, a resource portal used to gather and evaluate resources that the chatbot will then draw from. And then I will have a quick demo of different part of the Mira chatbot and Mira resource portal. And by mentioning our senior team and our partners, I will conclude my presentation. Okay, while 1 in 3 Canadians will experience a mental health issue in their lifetime, 1 in 3 also feel their needs are not adequately being met. We anticipate that there will be a significant demand for mental health services following COVID-19. Also, mental health system navigation is identified as a significant barrier to care for many individuals, and as such is what our chatbot seeks to address. Healthcare workers are hit during pandemic, so there is a risk of increasing anxiety, burnout, and depression for them. Also, there is a risk of post-traumatic stress disorder and threat of moral injury and the risk of trauma. Moreover, there is an inability to address their mental health issues when they come home. So the targeted participant group for this project are healthcare workers and their families. Technology uptake in Canada is already high, with 91% of individuals already actively using the internet and 85% with cell phones. Existing research where evaluations have been done suggests that digital technologies can bridge service gaps, increase point of access to the health system, and permit system integration. As such, our innovation seeks to tap into existing technological infrastructure in Canada and continue to build on the body of work that has been done thus far in this field. Currently, individual may seek information about mental health services and programs through popular search engines such as Google, Bing, or Yahoo, which may expose individuals to misinformation or low quality resources. They may call into mental health system navigation call centers and hire someone to support navigation in a hands-on manner, including making appointments and support navigation and advocating for them in meetings with health professionals. Some private companies offer navigation chatbots on their website interfaces. However, these chatbots have limited functionality and often have a conflict of interest in the provision of information on existing health services, as they push clients toward the use of their paid programs. Finally, we have found that there are tech companies willing to program chatbots to support mental health system navigation. However, they do so for a substantial cost. The Mira chatbot will support mental health system navigation using a state-of-the-art artificial intelligence model that I will explain in the following. It will complement existing public health services, not compete with them. It will support all mental health system partners as it is being offered to partners without cost following development. It will counter misinformation through use of validated resources that has been logged in the Mira resource portal, which includes quality assurance mechanisms. The bot will also be regressively evaluated, and we have included considerations for scalability in its design. As you can see in the picture, the three main parts of the machine learning model that we are using is comprehend the meaning, or intent detection, extracting important information, or entity extraction, and select a response according to the extracted and detected information. In this slide, I wanna describe the architecture that we used for intent detection and entity extraction. As I said, we are developing a chatbot to carry out useful mental health information and services to clients, to give the chatbot the ability to understand what client says or type. Different variation of each sentence have been defined, and a state-of-the-art machine learning model is trained based on the gathered sentences. Following this training, the client can then chat or speak with the chatbot like a human. Also, to further enhance the chatbot, some techniques like spell checking and entity extraction that extract useful keywords from a sentence are employed. Furthermore, text-to-speech and speech-to-text are added to the chatbot, so the client can speak with the chatbot and hear from it. All the conversations logged with the chatbot will save anonymously in a database, only accessible to the chatbot. The chatbot can then use conversation logs to refine its functionality further. We will use the conversation logs in order to retrain our model and improve the overall accuracy. In the following, I'm going to explain different part of the dual intent and entity transformer diet architecture that we are using within the Mira chatbot. This architecture is offered by Rosa framework, and it is open sourced within the Rosa framework. Consider play ping pong as an example. The intent for play ping pong is play game, and the words that should label as an entity is ping or ping and pong. Okay, consider this tag, the mask tag, as pong. I will explain the mask tag in the following. Each word will pass to two passes for converting to a numeric version of the word. The first pass is pre-trained embedding. You can use BERT, Convert, or any embedding models. For the Mira chatbot, we used BERT model. The other pass is sparse features. We used a character engram of the word and pass it to a feed-forward network. And then we concatenated these two passes. Okay, by doing so, we have a better representation of the word. We do these things for all the words, for ping and pong. And then the vectors, the numeric version of the words, will pass to a transformer. We use two-layer transformers, and the output of the transformer is also vectors, but the vector is according to other words. For example, for the play, the transformer consider ping and pong for its vector. So overall, we have a better representation of the words after applying transformer to the words. And then the vectors will pass to a CRF, conditional random field, and compare with their labels. For the play, since it is not an entity, it is not important, we assigned label O to it. But for ping, and consider this as pong, we assign them with the label game name. The output of CRF is entity loss, and the entity loss will add to the total loss. The other loss that we have is intent loss. Consider the CLS token. CLS token, the function of the goal of CLS token is summarizing the whole sentence, play ping pong, in one token. For example, if we use convert as a pre-trained embedding, we can sum the vectors of the words, and by doing so, we will have the CLS token. And by applying the same approach, we can convert it to a vector and pass it to a to the transformer. And by comparing the vector with the label, with the intent, play game, from here, we can calculate the intent loss. So the goal is making CLS similar to play game. Okay, and the third loss is mask loss. We randomly mask some of the words. For example, for this example, pong is masked, and pass it to the transformer. The purpose of this approach is forcing the model to generalize well. We force the model to predict some words in order to avoid overfitting. So the model can understand different variation of our training data as well, and it won't overfit to our training data. The mask will pass to the transformer, and you can see it will compare to the pong, and we will calculate the similarity, and the mask loss will calculate and will add to total loss. The goal of the model is decreasing the total loss. By doing so, we are training our model. Okay, this was the diet classifier that we use, and it is worth mentioning that according to the studies that have been done, if you can have an architecture that can do intent detection and entity extraction at the same time, you will have a better result, better accuracy. The other approach is having two architectures, one for intent detection, one for entity extraction, but the overall accuracy will be less than having one architecture that can handle both tasks. So we use diet architecture for intent detection and entity extraction. Okay, data. The main part of an AI project is having clean data. Unfortunately, we didn't find any specific data set available for training our chatbot. Therefore, we aim to create a data set and make it public for guiding future research. The dataset consists of 92 intents with 2,263 examples. The dataset may expand in the future since we are saving the conversation logs and put them in our dataset and retrain our model. We applied these four steps for creating the Mira data set: intent definition, example association, entity annotation, and data augmentation. Intent definition, the intents were defined according to the use cases of the Mira chatbot. For example, one of the responsibilities of the chatbot is handling suicidal cases. So we created an intent for it, which is named suicidal intent. The other component is example association. After defining all the intents, we try to define 3 to 5 examples for each intent, in which 357 examples were defined. The next component is entity annotation. In this step, important keywords that should detect with the chatbot were annotated. For example, if a user type, I wanna know about the symptoms of anxiety, the anxiety should mark as an entity. And the last part is data augmentation. After applying intent definition, example association, entity annotation, we have a small data set. And as you can see in this picture, we divided the Mira data set into two parts, test part and training part. And we applied data augmentation techniques that I'm going to mention some of them in the next slide, are applied only to train set. Okay, there are lots of text data augmentation techniques. One of them is back translation, in which you translate the original sentence to another language and translate it back to the original language. For example, I have no time as an example. We translate it to French and translate it back to English. And we have I do not have time as an augmented sentence. It is worth mentioning that by applying this technique, we couldn't augment our data set too much, since the original and back translated examples were same. So we applied other techniques for expanding the data set. The other approach that we used was using pre-trained language models such as RNNs and transformers. One well-known pre-trained language model is BERT, in which you can mask a word and pass it to the to the BERT model, and the BERT model predict the masked word. For example, for this sentence, this is really cool, this is pretty cool, will generate by the BERT model. Okay, for the Mira chatbot, we defined some branches, and according to the intent that the diet classifier detects from the sentence from the user, we will choose the next action from the branches, from the large tree that we defined. In order to have some kind of open conversation feature with the chatbot, with the Mira, we add another component, which is named Eliza. Eliza is the first bot that came close to competing with the Turing test by effectively recording input, rephrasing it, and matching keywords with the predefined list of responses. Because Eliza is a rule-based system, which means that according to the list of predefined rules, the chatbot will select a response. It is unable to have meaningful conversation with humans. Yet it managed to convey the impression that it is not a computer program. To solve this problem, we proposed an enhanced version of Eliza named Eliza, in which we added BERT model for detecting the emotion of the user. And by having the emotion, the detected intent and extracted entities by diet classifier and list of rules, we will select a response. By doing so, we could improve this part. We don't have any measurement for calculating the improvement, but according to users' experience, this part had an improvement. Okay. Mira library. Our chatbot won't be actively searching the open internet for resources to share with clients. Instead, in order to ensure the chatbot is offering evidence-based and verified resources, we have developed a unique portal where the resources can be stored and accessed by the chatbot. The definition of resource for the purpose of this project is broad and may include websites, graphics, phone numbers, and more. We capture up to 25 data points for each resource. Our chatbot is aware of these data points and uses this information to try to find best resources for client needs. Also, our intelligent portal user interface has features to reduce burden on volunteers inputting resources, including search functions, survey logic, and information pop-ups. This summer, we established a 25-member multidisciplinary expert advisory committee, inclusive of persons with life experience, member of indigenous community, nurses, doctors, mental health system navigators, and public health policymakers. All resources submitted to the portal are reviewed by a member of our expert advisory committee. Committee members will also helping us beta testing the chatbot. Also, they will also share information about our chatbot with their networks. Verification of resources is done via a review process reflecting that of peer review academic journals. That is, there will be 2 reviewers per resource with an editor to support. The portal resource quality assessment metrics was developed using items drawn from several existing validated tools for the quality assessment of online resources. The metrics include the opportunity for reviewers to check the resource for errors and rate the resource based on variables, including level of accessibility, use of evidence to support the resource, risk of bias, and more. The metrics tabulates the responses from reviewers and automatically provides a recommendation based on the metrics for the reviewer to consider for their final decision. Okay, I'm going to have a demo of a different part of the Mira chatbot. First Mira chatbot, then Eliza part of the Mira chatbot. I will explain the front end, the interface of the chatbot as well. And at the end, I will have a demo regarding the Mira resource library. Okay. Okay, this is the interface of the Mira chatbot. You can access it via mymira.ca. At the beginning, you should consent to the information by clicking on I consent. Then the chatbot will ask you which one of these best describe you. A healthcare worker, family member of healthcare worker, other, or prefer not to say. Or you can type anything in the text box below. Okay, if you choose a healthcare worker, and the chatbot asks you which of the following best describes you: nurse, doctor, health professional, or other. I typed I'm a nurse, and the diet architecture could detect the intent and extract nurse as an entity. So we showed a thank you message, and then are you looking for information for yourself or for someone else? I clicked on for me. Okay, here the chatbot asked about the location. Now the chatbot can understand all the cities and provinces in Canada. So if you type any city name, the chatbot can understand it. Okay, I typed I live in Edmonton, and the chatbot could understand it. Here, sorry. Here, there are lots, some options. You can learn more about the topic, or find a program or services, or learn about coping skills, or type something here in the text box. We are expanding the functionalities of the chatbot to understand and respond to more questions. If you click on I want to learn a coping skill, the chatbot asks you to provide more information. Okay, I typed I'm feeling stressed and need help managing my anxiety. Do you want information on online resources or books or others? I clicked on online courses. The purpose of asking too many questions is narrowing down the resources and show the user proper resources. Okay. Okay, the last question: are you looking for free resources, paid resources, or both? I click on free resources. Okay, based on what you told me, I believe you are looking for resources about stress and anxiety. Stress and anxiety are the entities that the chatbot could extract. And three resources are offered to the user, as you can see. You can click on them. Okay, at the end, in order to evaluate the chatbot, we ask some basic questions, and you can rate the chatbot. Well, this was the brief demo of the Mira chatbot. I chose a specific pass, and you can try other passes or play with the chatbot. And the diet classifier, diet architecture is trained to understand the sentences. Okay, the next demo is about Eliza part. Okay, if you click on I just want to chat, you will pass to the Eliza component. I'm here to listen. What's on your mind? I typed I'm having trouble sleeping at night. And the chatbot replied, "Thank you for sharing with me. Can you elaborate on that?" I type, "I'm really stressed out from work. I need something to help me. What would be getting it mean to you? It might allow me to get some better sleep. And then I'll be more ready to take on the day tomorrow." Can you elaborate on that? Work is hard. I work in a hospital and things have been really hard with COVID. Can you elaborate on that? At some point, we stop the conversation and ask the user whether he or she wants to show him or her resources. Okay. If the user click on show me the resources that you have found, the chatbot replies, okay, based on what you have told me, I believe you are looking for resources about stress. Stress is a keyword that detected by entity extraction, part of the diet architecture. We have 210 number of resources related to this topic. How would you prefer to narrow down your search? In order to have more specific resources, we offer two options to the user for narrowing down the resources. For example, if the user click on show me resources about general well-being, we can narrow down the resources more. Okay, and these keywords, general well-being and mental health in general, are extracted according to the gathered information from the user and also from our resources. If you click on just show me the top 25 resources you have found, you can see the resources. Okay, the next demo is regarding to Mira icons. By clicking on this icon, you can restart the whole conversation. By clicking on the bug icon, you can report any issue, write a comment and click on OK, and it will send to us and we will check it and fix it. By clicking on this icon, you can see the consent information.
Hey there, I'm Miro. I'm here to help provide you with information on mental health supports and services. I can't give you medical advice and I'm not a counselor, but I can help you figure out where to.
Okay, this icon is for reading from the text. It's text-to-speech part of the Mira chatbot. Okay, let me have a demo regarding Mira resource portal. Okay, this is the interface for Mira resource portal. You can view and check the logged resources here. Click on them, see the details. Or you can see your reviews and complete them or review them. You can check the items, and according to the checked items, a score will calculate. And if you reach the acceptance score, you can approve the resource. Okay, great. This was the brief demo of the Mira resource portal. At the end, I'm going to mention our senior team. Osmo Zayan, Ellen Australia, Vincent Agripan, Andrew Grinshaw, Simon Lambert, Dave Golem, Ken Porter, Debbie Turner, Leslie Brown, and Jasmine Noble. And our partners, Mood Disorder Society of Canada, Dalhousie University, International Indigenous Health Research and Training Center, Digital Hub for Mental Health, University of Saskatchewan, University of Alberta, AI for Society, Western University, MyTax, Mental Health Research Canada, and AIM. And thank you for your time, and I look forward to your questions.
Thanks, Ali, for the presentation. Everyone, if you have any questions, please feel free to unmute yourselves and ask your questions directly to Ali. I see Marjan has one question, so please unmute yourself and ask directly.
Hello, sorry, I just posted a reaction as a thank you. No question. Sorry.
Wonderful. Great.
Yeah.
Thank you, Ali.
Any other questions? If not, let's thank the speaker for a wonderful presentation. And Ali, I don't see your email if someone wants to contact you or reach out to you regarding collaborations or other questions. Do you mind putting your email in the chat box?
Yeah, sure.
Wonderful. So we have Ali's email in the chat box. If anyone wants to reach out to him, please feel free to write an email to him, and I think he'll be happy to chat more about his wonderful projects. So thank you very much for joining in today, and thank you, Ali, for presenting. And today we'll see you next week. Stay tuned, stay safe. Bye-bye.
Thank you. Bye.